little if we start late, so others may also join. So other class representatives for CS 456 should note down the names of students who will not be attending the class, right, and should be posting these roll numbers on the Google Classroom. Okay, so with this I'm starting. So actually we have discussed these concepts of normal forms. We have taken the basic terminologies related to the normalization process and different definitions of different normal forms, right? And in this examination of mid-semester exam 2, we have these questions being asked that what is the normal form of particular given set of FDs on a relation, what is the candidate key for that particular set of FD, and what is the possible closures, what is the possible other candidate keys, and how to identify the current normal form for FD and how to decompose to its normal form, to its highest normal form, right? And along with it, we have discussed these constraints of decomposition or normalization. So I hope you have gone through these notes. So in the previous lecture only, in the video of previous lecture, these all concepts has been partially or maybe initially it has been discussed. Few things which needs to be discussed, which needs to be understand it at your end. We will be taking those concepts in today's lecture. So the motive or the purpose of today's lecture is to simply go through the definitions of normal forms and what if we normalize a relation from the first normal form to its highest normal form, right? Because normalization process we will be conducting on a relation at a time, right? Like in a database, we could have multiple database tables. So to perform normalization, we will be taking one database table at a time. The very first task for the database normalization or database normalization is to identify the possible functional dependencies, right? And I hope you have this idea that how to define the FDs for a database relation. The basic approach we have discussed, and the basic approach is like this. For a particular database table, the obvious source of information to identify the functional dependency is naturally the database instance which is available. So to identify the FD between the possible FD between two attributes, you will be simply looking for the possible pair of values. That one value of attribute A should be uniquely determining a specific value of B. So whenever in that particular column A, that particular value is appearing in a tuple, it should be directly mapping to the similar value of the attribute B or column B. So like this is the common sense based approach for defining the functional dependency. So by using you can say by using this simple approach of looking at the database attributes values, you can easily identify the possible attributes, right? The second possible source of information could be the basically the information about the key, you can say keys, right? So because in database, actually what we have done, we have defined different constraints, different constraints on the different attributes, right? So what is happening? So whenever we define certain constraint or particular attribute, you have this idea that in this column, email ID or contact number or in pin code or some other columns, the values will be of this nature. So you can utilize this information that certain attribute is having this constraint. You can utilize this information to define the functional dependency between the possible pair of attributes. So that is the second step. So whenever we have some FDs defined based on these two information, you can always generate the other set of FDs, right? So to derive these other set of FD, can you tell me what are the things which we have discussed in lecture 23? So to derive the additional set of FD, what is the possible approach? What is the possible concept we have discussed? Can you tell me right now? You can post your answer in the chat box and let me know what is the possible concepts we have discussed in the previous lecture, which can be used to derive the additional set of FD or additional FD, right? Because on the basis of these values on the database table, you can derive few FDs. But by using these few FDs, you can derive some additional FDs also. So what are the concepts we have discussed? Can you let me know? Just post your reply in the chat box. Inference rules, right? So inference rules are naturally used to derive, to generate, to create additional set of FDs, right? So why we are creating this additional set of FDs, right? That should be the question. कि अगर आप ऑलरेडी बेस सेट ऑफ एफडी बना लिया आपने जो कि वैल्यूज के बेस पे हैं, तो हमें और एफडीज को डिराइव करके हम क्या अचीव करेंगे, राइट? सो यूजुअली whenever we use inference rule to derive additional set of FDs, naturally after that the candidate keys for the same FD set जो हमने derive किया था, और उसके बाद अगर उसमें inference rule लगा कुछ और नया set FD derive किया है, तो दोनों के candidate key में है तो दोनों एक ही database table के दोनों, बट अंतर ये है कि that this first is the first basic set of FD, and based on this we have derived new set of FDs. So if you go for the candidate key generation, तो जो बेसिक सेट है उसका की अलग होगा, और जो इन्फरेंस रूल बेस्ड जो एडिशनल एफडीज आई है, नया सेट बन गया है एफडी का, उसमें एक डिफरेंट टाइप की और नई कीज जनरेट होंगी, राइट? सो दो बोथ दीज टू सेट ऑफ एफडीज बिलोंग्स टू सेम रिलेशन, but we are having this inference rule on generate for the generation of new set of FD, and if you go for the candidate key generation for this second set of FD, it will give you the different candidate key, and it is assumed, it is observed that whenever we use this inference based FD set to identify the candidate key and to perform the normalization, your normalization will have more, I mean, it will impact to your the performance of the database. So that's why it is kind of a thumb rule that whenever you generate FDs, you should use the inference rule to identify these new set of FDs, right? So नया FD और जो basis FDs हैं उन सबको combine करके जब एक single set create करते हैं, that is something which you should use to perform normalization, right? So inference rule, the use of inference set rules is to basically have this rich set of FD and this proper candidate key for a particular database table, right? Through which you can say that the database is properly and normalized to achieve the better performance, to achieve the better efficiency for the database access, right? So that is something, because these inference rules has been proposed by some individual, some database researcher. For that he got this award called Turing Award, right? So because in computer science we don't have any because a Nobel Prize. In the basic science like mathematics, physics, chemistry, we have got Nobel Prize directly. But computing or computer related research, we have this award called Turing Award. So that individual who has proposed these rules, the name was like Armstrong Inference Rule. So he got 1985-83 he got this Turing Award for these simple 5-6 rules, right? So and these inference rule has changed significantly this normalization process and this concept of called the inference rules, right? So so overall this inference rule is having impact on this normalization process, right? So it is kind of mandatory. So whenever you go for normalization, whenever you go for a functional dependency identification, generating or using inference rule based FD is important, is right. So that is something which we have discussed and we have correctly pointed out. And now I think you have this idea that how to generate these additional set of FDs, right? So agar AB hai, to by adding C both sides, you can have new FD called AC determines BC, something like that, right? Similarly, you can use pseudo transitivity. Similarly, you can use a transitive FD. So likewise. So with this, we have discussed further the next concept that is called candidate key. So in the normalization process, the second step is called candidate key generation. So what is the role of candidate key? What is the purpose of candidate key? How candidate key is different from the primary key? That these are the questions which we have discussed, and it is very important to understand the difference between the use of candidate key and the use of primary key. Right? Do not confuse with these two terms. These two keys, primary key and candidate key, are being used in the different stage of database life. So whenever you are designing a database, designing means from the very first step to the normalization. So we are discussing the normalization from the last 3 lectures three lectures. So from the very first lecture, when we have started designing ER diagram, from that stage, maybe from before that also. So before means the step when we start writing the requirements about the system. So from that stage to this normalization stage, we are having these two concepts which are important. First concept is called primary key. So primary key is used to identify each individual, each object, each tuple in the entity, right? So I can say primary key is used to identify each object. Each object means, suppose we have this employee database table in the database company. Suppose we have employee database table. So within employee table, if you want to identify each employee, so each employee is what? Each employee is the object of particular employee database or employee database table. So we can say in a general way, we can say the primary key is used to identify each object in the entity, right? Each object in the entity. But whenever you want to access a particular information field for that particular entity, particular cell within that particular object, you want to have different key beyond this primary key. So that is something where we need this concept called candidate key, right? So candidate key is nothing, it is a set of, or it is an attribute, or it is a key which will help you to determine, locate, identify, retrieve the specific field for a particular object or particular call, particular row, particular cell, anything, right? So in a database table or in a database relation, if you want to access any specific value, candidate key is something which will help you. Candidate key is something which will retrieve some information, by field information, field data, field, anything, right? It will not help you out to identify each object. That is very sure, right? So that is something is a basic difference between primary key and candidate key. Yes, whenever you are generating or deriving a candidate key for particular table or for particular set of FD, yes, in candidate key the primary key attribute can be the part of it. So naturally अगर आपके डेटाबेस टेबल में 4 एट्रीब्यूट हैं A B C D और उसका A प्राइमरी की है, तो जब आप उसको नॉर्मलाइज करेंगे लेटर स्टेजेस में, तो ये हो सकता है कि उसके प्राइमरी की में A एक पार्ट हो. सो लेट्स से कि एक टेबल है जिसमें 4 एट्रीब्यूट्स थे A B C D, और जब आपने उसमें FDs ड्राइव की और FDs के बेस पे कैंडिडेट की जनरेट किए, तो कैंडिडेट की कुड बी AB, AC, AD, something like that. So it may be by accidental or it may be by logic also. You have observed or you have derived some set of candidate keys which are having primary key as a part of it, right? So it is not a rule. It is not a generic rule that you can say कि sir candidate की जब बनेगी तो उसमें primary key तो होगा ही. ऐसा नहीं है, right? There is no thumb rule for that. It may be happening by accident, by logically accidentally falling into this play कि आप जब भी आप कर रहे हैं तो कैंडिडेट की में प्राइमरी की वाला एट्रीब्यूट आ रहा है, अपीयर हो रहा है. सो इट इज नॉट अ रूल, राइट? दैट व्हेनेवर यू आर डिराइविंग the candidate key for a particular set of FD of a relation, this primary key attribute is appearing in the candidate key. It is not a rule, but it may happen in many cases, right? So it is something, so we can have this clear idea that okay, primary key is used to model the database, you can say. So whenever in the first two stages, during the ERD creation, during mapping of ERD into logical tables, so these two stages are called modeling. So during the phases of data modeling, we have this concept of called primary key, because there we are talking about the objects, the entity objects, tuples and instances. But when it comes to the actual data, retrieval of actual data on the same database relation, it is the concept of candidate key, which is important and which will have its role. Because now we are talking about the access of a particular data, access of a particular data object, access of a particular data field, access of a particular value in a particular row, something like that, right? So a candidate key is something closely related to the retrieval of data. right? It will help you to retrieve particular data field. So we have taken out the simple logic of deriving the candidate key. So whenever for a particular database relation FDs are given, I think based on the given FDs you can identify the possible set of candidate keys, right? And logic was like आपकी candidate key में क्या होगा कि जो functional dependency है जैसे A determines B है, B determines C है. So whenever you want to generate or derive the possible candidate key, you should be taking only left hand side attributes. Left hand side attributes are called determinants. In the FD, if FD is like A determines B, so A is a determinant. A determinant, it means by having the value of A, you can determine the value of B. So A is a determinant. For me, A is a key attribute. For me, A is important because the FD itself is saying that if you have A attribute, you can determine B. So A is determinant. So whenever you are defining or you are generating the candidate key, right? Whenever you're generating the key, you should be considering attributes which is placed in the left hand side of the set of FD or FD, right? So let me share. Let me stop sharing these notes. First, let me share something very interesting. Few questions which is of nature MCQ. So based on that, you may tell me about the fact that for this set of FD, you can have these attributes as a candidate key, right? So let me directly drag to that question. Few questions are naturally from examinations. So okay, so can you see this question number 5? Yes, this question. This is of this examination from GATE. This question, I hope it is visible to you. So okay, so if you can see here in a particular database table, we have F1, 2, 3, 4, and 5. So F1, so 5 attributes we have in this database table. And based on some data instance, these 3 FD has been derived. F1 determines F3, F2 determines F4, F1 and F2 combiningly defining or determining F5. So these 3 FDs are basically identified or derived. Now, based on these 3 FDs, if you go for the generation or identification of candidate key, so approach will be like, so because we have 3 FDs, you can start from the first FD. So the first FD says if you have F1, you can determine F3. So it means with having F1, we will be able to generate F1 comma F3. So this you can say, so this is something we used to refer as a closer, right? Something like that. So here we are using F1, right? So this indicates F1 closer. F1 closer means if you have F1, you can determine F1 and F3. So F1 is self, F3 is something which we are training. So similarly for this second FD, or maybe based on second FD, you can determine naturally it is very obvious and it is very common sense based that you will have F2 and F4, something like that. But right. So similarly, if you go for third FD, you can see by having okay, so let me go first here in the first FD. Okay, so like this, by having F1, you can have these 3 attributes. So now if you have these 2 attributes, if you see this FD and this FD, by having this first set in your hand, and you can say okay, based on first FD I have these 2 attributes F1 F3. तो वो दोनों को लेके अगर आप आगे की FD देखोगे तो क्या पॉसिबल है कि F1 और F3 जो आपके पास अभी हैं टेम्परेरी स्टोरेज में, क्या उनको लेके बाकी FDs को चेक करने से लग रहा है कि और एट्रीब्यूट एक्सेस कर सकते हैं? Then only you can say F1 is sufficient, F1 is a candidate key, right? If not, we can simply say F1 alone cannot access remaining attributes based on this first FD. Similarly, for FD2, you can say by FD2 where F2 and F4 are accessible, and I have seen by taking this internal or intermediate derived closure, I can say other attributes are not possible to be deriving the remaining. So like something like this. So after this, you can go for taking this closure. So it is kind of iterative process, right? So similarly, if you go for checking this closure of f1 comma f2, so you can observe that by having this attribute, you can have f1, f2, f3, right? That's one stage. So now I am having these three attributes. And if I go for verifying or checking the other attributes, so I have right now with me these three attributes, right? So by having these three attributes, if I check for other FDs like FD1, FD2, so I can claim that by having these F1, I can access F3, right? So F3 is already there. Now by having F2, I can access F4. It means, okay, sorry, yeah, so it should be like F5. Sorry. Okay, so 5. Okay, now if you check for the first FD, F1, determining F3, so it means by having simply F1, because in the intermediate stage I have F1, F2, F5. So by simply having F1 in my hand or temporary storage, I can claim F3 is also accessible. By having F2, I can claim that F4 is also accessible. It means for this particular database relation or for this particular database table, this F1 and F2 is the only set of attribute which can act as a candidate key, something like that, right? So this is a very basic approach. Maybe this approach is exhaustive, but this is how you can have the basic settings, basic way of determining the candidate key, right? So with this, now I'm looking for the next question, possibly for which you can tell me the possibility. Okay, now can you go for this? Yeah. So I hope these attributes are visible. Let me mark a slide. Yeah. So yes, so try to identify the possible candidate key for this. So here we have 5 FDs. No, not more than, it is more than 5. So first FD, FD2, FD3, FD4, FD5, FD6, FD7. So 7 FDs we have. Can you tell me the candidate key for this? Can you tell me immediately? Yes, I'm waiting for a response. So if it is, it is clearly visible to your screen. So can you tell me the possible candidate key for this particular set of FD? Yes, so I'm waiting for a response. So you can see here, so by having date of birth, you can determine age. By having age, you can determine eligibility. By having name, you can determine roll number. By having roll number, you can having name. So it is like transitive dependency. I mean, it is kind of transitive as well as trivial. So by having course number, you can determine course name. By having course number, you can have course instructor. So this is something called additive property. So because both course number. So course, by having simply course number, you can have course name and instructor. So by having roll number and course number, you can have grades. So one thing is something visual, which is like by having roll number and course number, you can get most of the attributes, but you need to check about date of birth. How something is required or important to have this access on date of birth, right? Okay, so you have posted a lot of responses, so it is something which is, I think, obvious and clear to you. Now we are going for the next step, or probably next concept, so which is a concept of called normalization, right? So with this, now we have this candidate key with us, and this candidate key is having two-way rules. So first rule is basically, so this candidate key which we have just derived, it is used to start the normalization process, right? It is used to start the normalization process. और आप क्या करेंगे, ये कैंडिडेट की तो आपकी बेस रिलेशन का जो अभी हमने नॉर्मलाइज नहीं किया, लेकिन जब आप उसको एक नॉर्मल फॉर्म से दूसरे नॉर्मल फॉर्म में ले जाएंगे, then your candidate key will be different because the database table will be normalized. Database table will be splitted or it may be decomposed. राइट। सो जब डिकम्पोज होगा तो एट्रीब्यूट्स मूव होंगे दूसरे दूसरे टेबल्स में। सो आपका बेसिक टेबल मल्टीपल टेबल्स में ब्रेक हो जाएगा, कुछ एट्रीब्यूट्स मूव हो जाएंगे दूसरी जगह, राइट, टू बेसिकली अचीव सर्टेन नॉर्मल फॉर्म। इस प्रोसेस में डिकम्पोजिशन होगा तो कैंडिडेट की भी चेंज होगी। सो आफ्टर a decomposition, after a normalization, this candidate key will be simply different, right? So this candidate key identification should be happening, it should happen of always after decomposition। तो हम देखेंगे। So eventually जब database आपका particular table split होगा और further टेबल 1 टेबल 2 हो जाएंगे, टेबल 1 टेबल 2 फिर फर्दर आप इसको ब्रेक करेंगे, तो जब आपके पास लास्ट डिकम्पोजिशन होगा जिससे फर्दर डिकम्पोज करना पॉसिबल नहीं है, then also you have to have this candidate key, right? And that candidate key will be used to code on or to be provided on the GUI, right? So because to access certain database we will be having these candidate key, राइट। भले ही डेटाबेस टेबल एक सिंपल जो था उसको ब्रेक करके हमने 4 डेटाबेस टेबल बना दिए, लेकिन तब भी आप उन डेटाबेस एट्रीब्यूट्स को यूज करेंगे जो कैंडिडेट कीज में रहेंगे उस डिकम्पोजिशन के स्टेज पे, राइट। सो इट इज द कैंडिडेट की व्हिच इज बीइंग यूज्ड टू बी रिटन और टू बी यूज्ड इन द क्वेरीज which are built on the GUI, which are built on the user interfaces, right? So this candidate key is always used. Maybe candidate key will be changing or updated after this each decomposition. Now with this concept that we have this candidate key at our hand, we are going for the discussion on the normalization or normal forms, right? So let me share this class notes of modified class notes of 24. So here broadly this normalization is something which basically ensures that after normalizing a database table, in the database table we will have some rearrangements, we will have some decomposition or partitioning, बहुत सारे terms use करते हैं हम, but primarily it is a simple decomposition, right? So decomposition का मतलब simple होता है कि आपने database table को break किया है, split किया है vertically, not horizontally. Vertically we have separated, so few attributes are going to a new subtable, right, and remaining will be going on this different subtable, something like that, to achieve certain normal form. And this process of decomposition makes your database table more efficient. It will not have these problems like अभी कुछ नहीं हो रहा है, प्रॉब्लम्स बाद में जो आती हैं वो हम पहले ही एंटिसिपेट कर रहे हैं कि अगर आप डेटाबेस को डिकम्पोज नहीं करते हैं, it will be possibility that in your basic database table there will be some redundant value. Redundant means मिस्टेक्स redundant नहीं होता है, कई बार हम डेटा को इस तरीके से रखते ही हैं कि वो by default redundant क्रिएट हो जाता है just because it is a nature or it is created like that. But in the future this redundancy, this repetition of values which was not done intentionally, these repeated values will be creating a lot of problems on manipulation transactions. These repeated values will create this extra effort of user, extra effort of system, and so these extra efforts will be a problem. और अगर कभी कुछ manipulation में failure हुए, it will create some spurious tuples, negative tuples, redundant tuples, right? So there is something. So it is said or it is observed that whenever we perform normalization, it will remove these possible invalid values, possible redundant values, which may raise or which may cause these possible anomalies, right? So that is something which is the advantage of normalization, right? So normalization whole is a process. It has some levels, it has some stages. You cannot decompose relation by simply having a guess that okay, let's separate these attributes to the separate tables, right? So it is a systematic process. It is a decomposition process which happens in vertically separation. So it is vertically it is partitioning a database relation vertically based on some conditions, right? So these are conditions which we have discussed in the previous class also. So it is a systematic approach, progressive approach, step by step approach, right? So when we conduct this normalization of a database table, initially we will start with our normalized database table. Our normalized database table में क्या होगा, बहुत सारी चीजें होंगी, like it will have some repeating value, it will have some composite value like address, or multi-value, like you can have multiple phone numbers, you can have multiple location, multiple addresses, right? So that is something which indicates that database table is unnormalized, right? So basically, in the very first step, when we have this unnormalized database table, we will check for the very first normal form, right? And first normal form is nothing but it is a simple condition which we need to check in a particular database table. आपके पास database table है, वो अनॉर्मलाइज था, आप चाह रहे हैं कि उसको उसमें फर्स्ट नॉर्मल फॉर्म कंडीशन मीट हो. So what is the first normal form condition? First normal form condition says each and every value in the database table should be atomic. That's the simple condition. If there is no value in the database table, should have multi-valued. Like we have taken, the phone number could be of 2, right? One student can have 2 phone numbers, one student can have 2 addresses, something like that. So this multi-valued and this composite value, both composite means like within one address field we have this house number, street number, state, city, and pin code. So this one single value is having multiple fields within one value. So this first normal form says in a database table you should not be having multi-valued and composite fields, right? So it is a simple issue, right, which I think we can deal with. So there are there are possible alternatives, or you can say solution for that एक आप अननॉर्मलाइज्ड डेटाबेस टेबल था उसको फर्स्ट नॉर्मल फॉर्म में कैसे ट्रांसफॉर्म करेंगे. तो उसका क्या है कि जो भी एट्रीब्यूट मल्टी वैल्यूड या कंपोजिट वैल्यूज रिटेन कर रहा है उसको आपको सिंप्लीफाई करना है, डिकम्पोज करना है, या बेसिकली उसको रीअरेंज करना है, रीअसाइन करना है, राइट? So that is something, there should be three or four approaches for that. Similarly, एक बार आपका डेटाबेस टेबल फर्स्ट नॉर्मल फॉर्म में हो गया, then you can go for the identification of second normal form कि सेकेंड नॉर्मल फॉर्म में है कि नहीं है. ओके, सो नॉर्मलाइजेशन का इंटेंशन ये है, नॉर्मलाइजेशन का ऑब्जेक्टिव ये है, you should be looking for the best degree for the normal form. For a database table, you should look for the best normal form. तो कई लोग इसको इस तरीके से समझते हैं कि your relation should always be in its your database relation should be always on the highest normal form. So highest means the best normal form actually. So whenever we say, okay, I have one database table, okay, now how should I go for the normalization to its highest normal form? तो आपको क्या करते रहना है कि आपको हमेशा नेक्स्ट जिस नॉर्मल फॉर्म में आपका डेटाबेस टेबल है उसके लिए उसको लेके आप नेक्स्ट नॉर्मल फॉर्म कंडीशन को देखना है, उसको कंडीशन को अप्लाई करके देखना है डेटाबेस में whether it is satisfying the condition of the next normal form or not. जिसमें आप हैं उसमें तो कोई प्रॉब्लम ही नहीं है. So if we have normalized this unnormalized database into first normal form, and first normal form condition हमने कह दी कि okay, it should not have any multi and composite value attribute. तो वो attain करने के बाद, वो condition meet करने के बाद, you can now go for checking the condition of second normal form. And second normal form condition says now first normal form में तो FD का कोई रोल नहीं है, ना ही candidate की कोई रोल है, right? It means now we once we have done with first normal form, now if we are saying our database table is in the first normal form, now we should be looking into the functional dependency set and its candidate key जो हमने initially derive करके रखा हुआ पहले से. तो basically in the second normal form, basically there is a simple condition. It says there should be no partial dependency between key and non-key. So key are what? Key attributes are, there should be no partial dependency between key attributes and non-key. So key attributes are the attributes which are part of candidate key, right? It is a simple definition. Key attributes are the attributes which are part of candidate keys. अब एक सिनेरियो ये है इसमें जो कॉम्प्लिकेटेड रहता है, एक एफडी में जब आपके पास एक डेटाबेस टेबल है उसमें एक एफडी सेट है, एक एफडी सेट में मल्टीपल कैंडिडेट कीज पॉसिबल हैं. सो लेट्स से कि एक डेटाबेस टेबल है लाइक R which has four attributes and some FDs are being designed or derived. तो ऐसा मानते हैं कि एक डेटाबेस टेबल में जो हमने अभी डिस्कस किया 4 attributes का है ABCD, and suppose for these 4 database attributes there are 2 keys possible, A, B and CD, let's say, right? So A, B and CD, right? So for this database table, which has 4 attributes, 2 candidate key A, B, and C, D, right? What are the candidate key, or what are the key set, what is non-key set? Because definition says key attributes are the attributes which are part of candidate keys, and non-key or non-prime attributes set are attributes which are not part of candidate key. तो इसमें तो दो चारों attributes ही हो गए. डेटाबेस टेबल है, उसमें 4 attributes हैं और FDs अरेंज हैं, और FD के बेसिस पे आपने जो कैंडिडेट की डिराइव करी उसमें A, B और C, D हैं. It means for the definition of second normal form, like there should be no partial dependency between key and non-key. So here we are having all 4 attributes as the part of key, right? There is no non-key attribute, right? तो इस definition को लेकर confuse नहीं होना कभी आपकी, what is key, what is non-key. For key, I am saying, if you are saying what is the key attributes for a database relation, all the attributes which are appearing in any candidate key is the part of key, right? It is the key attribute. Remaining attributes which are not part of any candidate key. कई बार ऐसा होता है कि एक ही की होती है एक एफडी सेट में, कई बार होती है कि एक रिलेशन में एक उसके एफडी सेट में मल्टीपल कीज पॉसिबल हैं. सो दिस इज समथिंग व्हिच इज एक्सेप्शनल, और कुछ केसेस में ऐसा होगा. सो यू शुड बी टेकिंग केयर ऑफ इट, दैट ओके हाउ टू ड्राइव द पर्टिकुलर की सेट एंड हाउ टू आइडेंटिफाई द प्रॉपर और अप्रोप्रिएट normal form. So for this you can see there is a question I'm posting to you, and it is like if we have this particular relation called student performance, and there are other attributes, name, course name, roll number, and grade, and you can see here there are 4 FDs. So if you derive for this particular relation which I am posted in the chat box, the candidate key will, there will be 2 candidate keys. So if you use these 2 candidate keys, the overall key set, overall prime attribute will have 3 attributes. Remaining will be the non-prime. Now, if you go for the definition of second normal form, which say there should be no partial dependency between these key and non-key, so there will be different way of identifying this normal form, right? So this aspect I have not discussed or pointed out in the previous lecture when we have having this discussion on the first time, right? Similarly, if that particular database is satisfying the condition of second normal form, which is there should be no partial dependency between key and non-key, then you can say that database table is in the second normal form in its basic form. Okay? If that particular condition is not verifiable, it is not adapting the condition of second normal form definition, second normal form condition, due to any specific FD, you should be decomposing, you should be taking the decision of decomposition of that relation, right? So let me scroll down the second normal form identification and decomposition. All right, so this is something which we have discussed in the previous lecture, that the table, so table is now in the first normal form. Now you can progress towards normalization of second normal form. So if it said it should be no any functional dependencies which create partial dependency among key, right? Key and non-key attributes. So that is something very crucial. So based on this, if you take this particular FD set, so this FD set is derived from this basic table which is visible to you right now. So first FD says SSN and P number determines R. Second FD set SSN determines E name, and third says P number determining P name and location. Now based on 3 FDs, now you can see the definition that okay, see you can see what is the candidate key for this particular FD set. So key attributes are basically SSN and P number. So in this case we don't have any candidate key right now. We have only one candidate key, so that one candidate key is having it is assumed to be the key attributes. अगर 2 होते कैंडिडेट कीज तो उन दोनों कैंडिडेट की जितने सभी एट्रीब्यूट्स हो रहे हैं फर्स्ट कैंडिडेट की सेकंड में सभी कंबाइन करते हैं हम, उसको कहते हैं इट इज अ की एट्रीब्यूट. So if candidate key is determined, now you can apply the definition of second normal form. So by this you can see in the very first FD SSN P number, see the whole key is used. Whole key is used to determine a non-key. So except this SSN and P number, all other attributes are non-key. So if you see for FD, whether FD1 is satisfying the second normal form condition or not, you can say because SSN and PIN number is a key for this database table. For this particular FD, we are using this whole key to determine a non-key attribute. So this FD1 is okay. If you go for FD2, in FD2 it is having SSN is determining a name. So SSN is what? SSN is a part of key. SSN is not a whole set. So SSN is attribute which is a part of key. So it is a set of, it is element from the key subset attribute. So you can say FD2 is violating the condition of second normal form because a part of key is used to determine the non-key attribute. Similarly, if you go for FD3, it is also violating because P number is a part of primary key. It is partially determining the non-key attribute. So these two are the culprits. These two are the creating this violation of second normal form. So यहाँ से हम क्या करेंगे? यहाँ से हम डिकम्पोज करेंगे इस बेसिक डेटाबेस टेबल को जिसमें ये FDs थी 3 और डिकम्पोजिशन कैसे होगा? जो भी FD कंडीशन फुलफिल कर रही हैं उन सबको एक डेटाबेस टेबल में रखेंगे हम. उन सब टेबल इन सर FD मतलब उस FD में जो भी एट्रीब्यूट्स हैं जो सेटिस्फाई कर रही कंडीशन उन सब एट्रीब्यूट्स को हम एक टेबल में प्लेस करेंगे which is table 1. All the FDs, all the remaining FDs which are creating the violation will create a separate database relation for each FD which is creating the violation. तो अभी तो हमारे पास 3 ही FDs हैं, right? और FD1 is satisfying the condition of second normal form. FD2 is not satisfying, FD3 not satisfying. So the thumb rule says all the FDs which are meeting the condition, which is adopting the condition of normal form, should be kept in 1. तो अगर इसमें 4 FDs होती उसमें से 2 फुलफिल कर रही होती कंडीशन तो उन 2 FDs FD1 FD2 में उनको हम एक साथ रखते हैं सभी एट्रीब्यूट्स को और रिमेनिंग FDs जितनी भी हैं जो वैलिड कर रही हैं सबको सेपरेट टेबल्स में उन एट्रीब्यूट्स को मूव करते हैं हम. दैट इज हाउ we used to perform decomposition, right? So each violating condition, each FD which is violating the condition of normal form should be kept in a separate normal form. That is the thumb rule, right? Now once we have done with decomposition, so here we have performed decomposition. Now once we have this decomposition, you should be looking for these two properties, and these two properties are called decomposition constraints. So decomposition constraints are important because you cannot perform any normalization just by having this process of decomposition. There should be a check, right? ऐसे तो आप किसी डेटाबेस टेबल को कहीं तक नॉर्मलाइज कर देंगे? नो. इवेंचुअली क्या है कि जब आप डेटाबेस डिकम्पोज करते हैं, फ्यूचर में जब आप डेटाबेस को एक्सेस करेंगे तो there will be a need of rejoining these decomposed relation. तो ये हो सकता है कि आपने जो बेसिक डेटाबेस टेबल था उसको 3 टेबल में ब्रेक किया, R11, R12, R13. फ्यूचर में कोई क्वेरी हो सकती है जिसमें R12 और R13 को ज्वाइन करना पड़े, R12 को R1 से ज्वाइन करना पड़े, ज्वाइन ऑपरेशन परफॉर्म करना पड़े, R11 को R13 से करना पड़े. सो दैट्स व्हाई, बिकॉज ऐसा तो है नहीं कि डेटाबेस डिकम्पोज हो गया, डेटाबेस टेबल डिकम्पोज कर दिया हमने तो फ्यूचर में कभी ज्वाइन ही नहीं करना पड़ेगा. सो in order to take care of these possible rejoining or recombination of attributes, recombination of database tables, these constraints has been placed or designed. So there are 2 constraints. First one is called dependency preservation and second one is called lossless. So dependency preserving says that before this decomposition, whatever FD we have, so we have 3 FDs in this case, right? So before this decomposition of relation R, we have 3 FD, and after the decomposition of relation into 3 relation R11, R12, R13, now you have to see, are we losing any FD just because we have separated the attributes? So it is important. So जो decomposition से पहले या decomposition के बाद जो set of FDs different attributes, different tables से बनते हैं, if both set are similar, both set are same, you can claim that we are not losing any dependency. That's simple condition you should check, right? Second constraint says whenever we are decomposing a relation into a sub-relations like we have just done, there should be some common attribute. There should be at least one attribute common between pair of tables. So it is like R11 और R12 में एक attribute common होना चाहिए, R12 R13 में एक common होना चाहिए, R11 और R13 में एक attribute common होना चाहिए. Then only you can say this particular decomposition is lossless. We are not losing the connection. We are not losing the common attribute between the pair of tables which we have just created, right? So if these two constraints are yes, these two constraints are okay, or yes, or positive or green side, you can say this decomposition is successful. Now my database table in its highest form, which is second normal form, राइट सो ये अप्रोच है हमें फर्स्ट से सेकंड में लाने में। अब जब आप थर्ड के लिए चेक करेंगे तो थर्ड के लिए इंडिविजुअली चेक करेंगे, R11 की कैंडिडेट की बनाएंगे, उसमें जो एफडी है, R12 की जो एट्रीब्यूट्स हैं उसके बेस पे जो एफडी बन रहे हैं उस पे आप कैंडिडेट की बनाएंगे, R13 पे बनाएंगे और उसकी जो एफडी है उसकी कैंडिडेट की बनाएंगे। सो बेसिकली इट इज काइंड ऑफ जैसे मर्ज शॉर्ट में होता है, पहले आप स्प्लिट करते हैं फिर वहां इंडिविजुअली चेक करते हैं, वैसे ही बेसिक रिलेशन को हम ब्रेक करते जाएंगे, हर एक पे वही लूप चलेगा कि फर्स्ट नॉर्मल फॉर्म, सेकंड नॉर्मल फॉर्म, थर्ड नॉर्मल, समथिंग लाइक दैट। सो बिकॉज दिस नॉर्मलाइजेशन थ्योरी सेज यू हैव टू कंपेयर और यू हैव टू वेरीफाई अ रिलेशन एट अ टाइम, राइट। सो पहले हमारे पास एक रिलेशन था, अब तीन हो गए, तो तीनों के अलग अलग परफॉर्मेंस करने पड़ेंगे हमें, तीनों के अलग कैंडिडेट कीज बनेंगी, एफडीज बनेंगे, कैंडिडेट कीज बनेगा, फिर उसको वेरीफाई करेंगे सेकंड, फर्स्ट, सेकंड, थर्ड, इस तरीके से, right? So but as of now I can claim that the basic relation is now in the second normal form, due to which we have created these three sub relations, right? So now if you see with this you can go for the third normal form, right? So whenever you observe that particular database table in the second normal form, currently is in the second normal form, so should I check for the third normal form or not? So you need to see this condition of third normal form, and it says that there should be not any transitive dependency between key and non-key. So transitive dependency means what? Transitive dependency says if you have attribute A, and by having A, if you are able to return B, and in other FD, if some FD is available like C to D, it means not C to D, B to C, it means you are able to determine C. So because A determining B and B determines C, so by using B you can have reach up to attribute C. So this is kind of transitivity. So the condition is saying that if you have this key set are something which is derived from the all attributes which are falling in the all the candidate keys, like previously we have discussed. So there should be no transitive dependency between key and non-key, right? So it is a third normal form. So it is like if you have some attributes which are falling in the key set, and now if you are accessing a non-key attribute, it should not be, it is not like a key से non-key हो, non-key से फिर एक और key हो, something like that. So अगर आप मानो कि एक database table में 4 attributes हैं, रिलेशन आर में A B C D हैं, A B C D, और A is the key. Let's assume A is a key. So there should be no FD like A to B and B to C. So यहाँ पर क्या है, A तो key है, B, C और D नॉन की है। तो ऐसा उस key और उस FD सेट में ऐसा ना हो कहीं पर भी कि A से B ड्राइव हो रहा, B से C हो रहा है। So it is like you are deriving a non-key by having A, you're deriving the C which is through B. Right, and this is something not allowed. तो इसमें ऐसा नहीं होना चाहिए कि की एट्रीब्यूट है जो दूसरे या तीसरे की एट्रीब्यूट ड्राइव कर रहा है by using other non-key. So it is creating a weak link, right? It is creating a weak link. You are using a weak person or weak individual to deriving or to relate a weak attribute, something like that. So this transitivity is a problem. And third normal form says you should not have any transitive dependency between. So in a database table, if you have FD set, if you have candidate key, you should look for these possible situations which are creating this transitive dependency between key and non-key, right? So this is something it should be checked, right? So for that, you again see we have these 4 FD set, and for these 4 FD set we have derived this candidate key called SSN. And okay, you are assuming that this particular database table is in the first and second normal form. This you can check also. So if you see this SSN is determining E name and birth date, right? So SSN is a candidate key, it is a prime attribute, and non-key are others like E name, birth date, D number, MGR, and D location. So you can see this FD1 is okay because by using SSN, which is a key, you are determining non-key. FD2, by using key, you are determining non-key. But if you see for FD3, or maybe due to FD3, you can say, so because SSN is giving you D number, and due to FD3, it is having D number to DMGR SSN. So here you can see FD3, both attributes are non-key attributes, right? And just because you can see FD2 and FD3, if you combine these two, you have a transitive dependency between SSN and DRMGSN through D number, which is a non-key. So it means FD3 is a culprit. If FD3 is here, it is creating this transitivity between SSN and DMGR. Similarly, if you see FD4, it is creating transitive dependency between D location and D location and SSN. Right. So these two FDs individually are the problem. So decomposition क्या होगा? जिनने प्रॉब्लम किया उनको सेपरेट करो. So we have three possible relation. First database relation में, सब रिलेशन में ये दोनों होंगे, FD1 FD2. तो वो आप इन चारों एट्रीब्यूट्स को मूव कर देंगे, SSN, e-name, birth date and D number, right? और दो रिलेशंस और बनेंगे, एक में ये जाएगा FD3 वाला एट्रीब्यूट, एक में जाएगा FD4 वाला एट्रीब्यूट. डिकम्पोजिशन करेंगे, डिकम्पोजिशन के बाद आपको वही दोनों कंस्ट्रेंट चेक करना पड़ेगा, whether it is lossless, whether it is dependency preservation, something like that, right? So decomposition rule, and after decomposition, the verification rule is same for all decompositions. This condition, this normal form condition is the only difference. Similarly, if you go for the BCNF, so BCNF says, so normally to verify for the BCNF, your relation should be on the third normal form, that is the basic condition. और उसके बाद BCNF में चेक करेंगे तो क्या होगा? So BCNF simply says it is the strict maximum strict normal form, right? It is considered as the stricter than third normal form. So BCNF says that each and every FD, in each FD, you should have key attribute as a determinant. So if you can see, अभी तो ये particular third में ही नहीं है, अगर हम लेते हैं तो उसमें कह रहा है कि हर FD का जो लेफ्ट हैंड साइड एट्रीब्यूट है, like this, it should be the key attribute. That's it. It should be key attribute. अभी तो यहाँ हम अलाउ नहीं करते हैं, अभी तो हम फ्री रखते हैं कि की नॉन की कहीं भी हो सकते हैं, but it should not have transitive, it should not have partial. But अगर आप BCNF चेक करने जाएंगे, BCNF नॉर्मल फॉर्म अप्लाई करेंगे किसी डेटाबेस रिलेशन के FD सेट में, it will simply ask for the condition that on each FD of the FD set for a relation, left hand side or determinant should be the key. That's it. That's the simple condition for the BCNF. और अगर नहीं तो उसको आप ब्रेक करिए. So that's why it is called that BCNF, which is called Boyce-Codd normal form. So Boyce-Codd is the individual person name who has proposed this theory of normalization, and for that he has got Turing Award. So Boyce-Codd normal form, which is called BCNF, says each and every determinant on each FD should be the key. That's the simple condition, and it is considered as the most strict normal form, right? So so again, decomposition will be same. This decomposition verification will be same. So this second part is same, but only normal form condition application is the difference, right? So with this, I am closing this today's class. Now you have to go through different different questions in the examination, or different question from the internet. You can take out like exercise question for normalization, data normalization. So you can find out the different platforms. There we have given a lot of questions that how to normalize a particular data relation to its normal form. Okay, so now I'm looking at the question. Bharat says, sir, FD3, FD4 can be inserted in one table instead of two tables as both having same attributes. And so no, it's not like that, right? So we cannot have, because FDs are separate. It has been created for the, because it is not only about left hand side attribute. It is sometimes about the right hand side attribute also, which is determined, right? Determinant and determinant. So you should not be merging these two FDs into in particular database, single database table, right? So that is something which is important, which is basically relevant on